Here we're looking at antidifferentiation or integration. We're going to look at what is it, how do we do it, and why. Those are the three questions we're answering in this tutorial. What? It's the opposite of differentiation. We reverse the process. So how do we do it? Well, we're going to reverse the process of differentiation. We're going to start with number 2 and work backwards to number 1. Instead of reducing the power by 1, we're going to add 1 to the power. Instead of multiplying, we're going to divide, but we're going to divide by the new power. We're also going to add a constant. That's because when we differentiate, a number is lost. A constant goes to 0. We don't know what it is, so we just say it is C. So antidifferentiation, add 1 to the power, divide by the new power, add a constant. Now please don't get this mixed up with differentiation. A lot of students don't have enough practice and they differentiate when they should antidifferentiate, and they antidifferentiate when they should be differentiating. So make sure you know what you're doing. They're reverse processes. Practice so you don't get them mixed up. We're going to integrate 4x squared with respect to x. The integral sign and the dx means respect to x. You can just basically ignore those things. We're going to write y equals 4x squared. Now I'm going to add 1 to that power to make it 3, divide by the new power, add a constant. Wow, you've just antidifferentiated. The next one, we're going to antidifferentiate this big long one. It's got 3 parts to it. We ignore the brackets. I'm going to write out the question first. Y equals, note I've changed coloured pens because it's a completely different equation. I'm going to add 1 to the 5, divide by the new power. Add 1 to the 2, and divide by the new power. Add 1 to the 1, divide by the new power. Add a constant. Then I'm going to tidy it up because the 5 will cancel out on the first term, and we've antidifferentiated another one. Next we're going to have a look at a number. A number or a constant antidifferentiates to an x term. So if we want to antidifferentiate with respect to x4, remember we forget about the integral and the dx. 4 is the same as 4 times 1, or 4 times x to the power of 0. We know that x to the power of 0 is 1. Add 1 to that power, divide by the new power, and so we get 4x plus your constant. So a number antidifferentiates to an x term, and when you differentiate 4x, obviously you're going to get 4. Let's have a look at this one here. We're going to antidifferentiate these numbers. Forget about your integral sign in the brackets. Write out what it equals. Y equals, just write that out now. Add 1 to the 2, make it 3. Add 1 to the 1, make it 2. And put an x there. Remember when we differentiate, the x disappears, 1x disappears. Well, here 1x reappears. Don't forget to add your constant. We can tidy that up a little bit because 2 cancels out with a 2 for the x squared term. How about integrating the square root of x? Well, we'd have to change that first, wouldn't we? To x to the half. Write it out, y equals x to the half, add 1 to the power. Now we don't normally divide by 1.5, so I'm going to change that to an improper fraction, 3 over 2, and divide by 3 over 2. And I'm putting it beside each other because we normally don't have something over a fraction. I add a constant. Now I'm going to take that fraction, turn it upside down and multiply. And then there's my 2/3, and the 2 for the x power means square root. It's the square root of x cubed. And that's how we tidy it up. Now why? Why do we antidifferentiate? We need to find an original function, especially when we're given a differentiated function. And the second reason is to find an area. An area under a curve, sometimes an area between two lines. That's why we differentiate, antidifferentiate. Don't get those processes mixed up.